Then on the question they say we have to prove. Okay, now let us start with the left hand side. Now what we can do on the left hand side, within the first bracket, we will convert all these trigonometrical ratios into terms of sine and cos. See, this cot can be written as cos x upon sine x. Cosec can be written as 1 upon sine x. Same we will do in the second bracket also. This tan can be written as sine x upon cos x. And this sec x can be written as 1 upon cos x. Okay, after converting these trigonometrical ratios on the left side in terms of sine and cos, let us take LCM in the first bracket. LCM is sine x. So you will be getting sine x plus cos x and minus 1. Similarly, let's take LCM in the second bracket. So it will be cos. So we will be getting cos x plus sine x plus 1. Okay. Now what to do? Now we are going to multiply these two. Now there are two ways of multiplying. One is simply multiply these three terms in the numerator with the three terms in the numerator on the other side. Simple multiplication. Or the second way is you consider sine x plus cos x as a single term a. So this becomes a minus b and this becomes a plus b. See, multiplication you have two methods. So what I am doing here, I am considering this sine x plus cos x in the first bracket as a, and then again sine x plus cos x in the second bracket, this is a, and considering this one as b. So what we can do here, this will make our multiplication a little bit easy. Sine x plus cos x considered as a, so this will become a minus b into a plus b. So that will give you a square minus b square. So a is sine x plus cos x, a square minus b is 1. So see, I have applied this method. Sine x plus cos x was considered as a. So the first bracket is considered as a minus b. In the second bracket we have a plus b. So we have applied the formula a square minus b square. Okay, in the denominator place, this will be sine x into cos x. और यहाँ पे अगर आप चाहें तो सिंपल मल्टीप्लिकेशन भी कर सकते हैं. अगर आपको ये फॉर्मूला यहाँ पे नहीं समझ में आ रहा है एक्सपेंड करने के लिए, तो आप सिंपल मल्टीप्लिकेशन कर दीजिए. पहले साइन एक्स से इन तीनों को, फिर कॉस एक्स से, माइनस 1 से. ओके, नाउ साइन एक्स प्लस कॉस एक्स का होल स्क्वायर. सो वी विल बी गेटिंग साइन स्क्वायर प्लस कॉस स्क्वायर प्लस ट्वाइस साइन एक्स कॉस एक्स minus 1, right? And in the denominator place we have sin x into cos x. Now this sin square plus cos square identity, so this will give you plus 1, and this plus 1 with minus 1 will cancel out, so we can show it in the next step. Sin square plus cos square will give us 1, then we have minus 1 plus 2 sin x cos x upon sin x cos x. So this plus 1 minus 1 will cancel out, so you are left with 2 sin x cos x upon sin x cos x. This will cancel out, so finally you are left with 2, that is equal to right hand side. Hope this is clear to you now. Okay, now in this question again, this is the left hand side and we have to prove it to the right hand side. So again we are starting with the left hand side. See, on the left hand side, tan x plus sec x minus, now this 1, we are going to replace 1 with the identity sec square x minus tan square x. Now from where we got this term, see, you must be knowing the formula 1 plus tan square is equal to sec square. So if I rearrange this formula, 1 is equal to sec square minus tan square. So here what I have done, I have replaced this 1 in the numerator place. This 1 has been replaced with sec square minus tan square. Okay, denominator remains as it is, tan x minus sec x plus 1. Now what we will do, see, in the numerator part we will apply a square minus b square. So this is tan x plus sec x minus, now this sec square minus tan square can be written as sec x plus tan x into sec x minus tan x. We applied a square minus b square here. Denominator remains as it is. That is tan x minus sec x plus 1. Okay, now in the numerator place we will take tan plus sec as common. See, tan plus sec as common. So I am taking tan x plus sec x common. So what we will be left with from here, you will be left with 1, then minus sec x minus tan x. So in the numerator part we have taken sec x plus tan x common. Okay, denominator as it is. Now in the numerator part, if I open the bracket here, I will be getting 1 minus sec x, this will become minus minus plus tan x, and the denominator remains as it is. Now what I can do, in the denominator place I will rearrange these terms. So I will write 1 first, then after writing 1 I can write minus sec x and then plus tan x. So in the denominator place I have rearranged the terms. So what will happen, now see, in the numerator 1 minus sec plus tan, denominator also, so this will cancel out. So you are left with tan x plus sec x, but we haven't got the required result. See, required result is 1 plus sine upon cos. So what we can do over here, let's convert these trigonometrical ratios in terms of sine and cos. So this tan x can be written as sine x upon cos x. The sec x can be written as 1 upon cos x. Now let's take LCM over here. LCM will be cos. So you will be getting sine x plus 1. So this was required. You can rearrange it. You can write 1 first and then sine. So that is equal to right hand side. So this is clear to you now. Now in this question, again it's a proving one. we have to prove LHS is equal to RHS. So let's start with LHS. So on the left side we have 1 upon cosec minus cot minus 1 upon sine. Now what we can do on the left side, in the numerator part here, 1 can be replaced with cosec square minus cot square. See, this numerator 1 has been replaced by cosec square minus cot square, and from where we got it, you must be knowing this identity. 1 plus cot square is equal to cosec square. So here 1 can be replaced with cosec square minus cot square. So we have used this identity over here, and this 1 upon sine, this can be written as cosec. Okay. Now this cosec square minus cot square, you can write it as a square minus b square. So this will give you a plus b into a minus b. Denominator you have cosec minus cot, and then you have minus cosec x, right? So we have used identity, we have used over here this factorization a square minus b square. See, so what will happen, this cosec minus cot, this will cancel out in the numerator and denominator place. So here you will be left with cosec plus cot and then minus cosec. So this cosec will cancel out. So solution for the left hand side is cot x. So we have got the solution for the left side as cot x. Now let's solve for the right hand side. The right hand side we have, see, right side is 1 upon sine minus 1 upon cosec plus cot. This is cot, cosec plus cot. So right side is 1 upon sine minus 1 upon cosec plus cot. Now this 1 upon sine can be written as cosec minus, now again using the identity here, 1, as you can see, 1 can be replaced with cosec square minus cot square. So 1 will be replaced with cosec square minus cot square whole upon cosec plus cot. Now what we will do here, we will apply a square minus b square. So we will be getting a plus b into a minus b whole upon cosec plus cot. Now here you can see this cosec plus cot, this will cancel out in the numerator and the denominator place. So what we are left with is cosec, and now if you open this bracket, you are minus this. So let's open the bracket here. When you open the bracket, you are getting minus cosec minus minus plus cot. Cosec will cancel out, so you are left with cot x. So see, when we simplified the left side we got cot x, we simplified the right side, again the cot x. So we can say we have shown LHS is equal to RHS. This is clear to you now?